Hello there, folks. Hey, this is Joe Wazoo here. Hey, I'm just doing a updated version of the oil and water chart, this time in Crimson 3.2, but doing something different here in this one. I've always wanted to try this. I got a couple thermocouples I'm using for inputs, and so I wanted to try to see if I could use that to simulate some analog values here to play with this idea. So I'm using a graphite 7-inch, and down here in modules, I've got a GMUIN. Actually, I should back up a little bit. Here in Crimson 3.2, you have to add the modules to it. So over here in device configuration, click on the base unit, and this is where you pick your modules. And then, of course, Crimson will recompile, and you got to commit the changes, and then it shows up. So I've got this GMUIN, and then down here in the lower left-hand corner, under modules, I just want you to see that I've got input 1 set up as a thermocouple with Type J connected to it, and on input 2, I have a Type J also connected to it, and both of them are set to give Fahrenheit. I'm not doing anything with input 3 or 4, but you can change to whatever type. But I'm using just input 1 and 2 here. So over in data tags, I've got I've got just an integer tag here, and I've got it mapped to that channel by hitting the pull down here and choose the module 1. That's the default name. You could, of course, rename it. And then when you do that, I'm going to click the input, status, and PV1. Process variable 1 is what I'm looking for. And if I go to channel 2, I'm looking at PV2 here for that. So on this application, those two tags are right here on the screen. You're going to see the raw value of those on the screen. So if I download this to it, there it is. If I put the web page, here's those two analog values right now. I don't have a decimal point in here, so it's really 79.6 degrees, but I'm just doing the raw value so I can do formatting. So I went a little further here. Then I thought, okay, how could I take that value and have it mimic a 4 to 20 milliamp sensor? So I created another tag over here called AI1, and on AI1 down here I created a couple tags called min temp and max temp, so I can adjust that. And over that range, I want this to put out a 400 to 2000 value. Notice 400 to 2000 here. If I go to the format tab, I have min and max here is 400 to 2000, but down here I've got digits, 2 digits before and 2 digits after. If I slide all the way down, you can see that I added a units or a suffix of milliamps. So that's what I did there, and I also did the same thing on milliamp 2. There is one trick here I'll teach you. Once you drag the appropriate tag into here, you can't really adjust these anymore. So I always set these parameters up first before I assign it to the value. I don't know why, but it kind of grays out. So I set this up first before I do that. So now that I've done that on the screen, that is going to be shown right here is the milliamp. So let me go back to our web server here. And if I squeeze, say, for instance, AI1, which is that guy, you can see that it just, and I purposely put in the range of 800 to 950 here. So currently it'll go down to about 80 degrees. And about the hottest I can get this thing is about 950, pretty close. But you can see here's the representation of the milliamp version of that. And then this one here, here's AI2. So if I squeeze it, and you can see it converts it to milliamp here as well. So that's what I'm doing right there. Let me go back to Crimson here. And then I went a step further here. And then I got to thinking, well, what if I wanted to do water and oil? So I take these same values. If I click, I create another tag called water. I mapped that to the milliamp one. And notice down here, team, because the milliamp is coming in as 400 to 2000, I put 400 to 2000 here, but I want it to display as 0 to 100%. So I did 0 to 100 here in this case. And then if I go to the format tab, you can see I set the min and max here as 0 to 100. Down here, I put 3 digits before, none after. And I think, whoops, let me click away. Down here, I added a % sign. So I'm doing that with both the oil and water. Same thing on both of them, same concept. So back on the display pages, this here are those raw numbers coming from that guy. Again, if I go back to the web browser, you can see that as I squeeze the water, I also made a chart here, but you can see it's up to 65% in there, the raw values here, and there's the milliamp version of it. And of course, if I do the same thing, squeeze the thermocouple for the oil, you can see that it adjusts as well correctly. Okay, so now if I go back to Crimson, I added 2 charts here. Now, if you watch, I've got other videos on the oil and water chart, and from those videos and my finding, Normally you would use a rounded rectangle for this in the core primitives, but I found for some odd reason that operates a little bit differently than the old legacy. So for this application, I go into the legacy primitives, and in the legacy primitives, I slide down, and there's a rounded rectangle here, a C3.2. That's the rounded rectangle that I use in all these for this application. I don't know why, but this one seems to work out better for filling. So this one right here, if I double click on this guy, you can see that it's linked to the water. So all I did is I dragged this guy right here, boom, and it gets the min and max from the tag level. And I'm having this one fill up with blue and a gray background. And the other one here is going to be the oil. I've got it filling with black and a gray background. So that's those two standard there. And that's what you're seeing on the web browser. These two charts are here. So if I squeeze the oil, this guy goes up and down here. And if I squeeze the blue thermocouple channel 1, you can see the water level there. Okay. Where things got a little bit weird on this application is when I went to put them together, as I do in the other videos. So here I got two. Let me slide this over a little bit so you can see something. So in the background here, the first one I put on is water. What is this? I got water here, and it goes min and max. I got blue, black for that guy, background color. And then the other one that's kind of in front, I'm doing the oil fill from bottom, oil max min. But notice this no fill, and I'm using a silver background color. So that's kind of weird, but I found this is the cheat that I can do to make this happen. And then this one here is right in front of this. So that has to do with the Z order. So if I take this one, right click and go to align centered on, put it directly on this guy, this is how it's worked in the past. So if I save it, download this to it real quick, I want you to see something. This is what threw me for the loop on this whole thing. So if you watch here, once it gets updated, so here's this combination here. Now here's the problem. If I warm up the water, you see it doesn't move, but if I squeeze the oil, you can see that the oil then changes. But the problem is when the oil level drops below the water level, it takes precedence, and all of a sudden now the oil is what's causing this to go down. You can see it matches that guy. So then I had to think about this, and normally, team, with an oil and water, the oil will always be on top of the water, so you won't have this problem. If you're using a tank stick where you have two floats and you got the top one is the oil level and the bottom one's the water level, there's no possible way that the oil one could go below the water level. That never happens. But in this case, because I'm simulating here with these thermocouple inputs, I had to figure out a workaround of how could I make that happen? How could I cover that base? So if I go back here to data tags on the left, I created another tag called oil1. Okay, this is the oil tag. And if I notice I got this complex code here, if I hit the edit button, this is where things got a little interesting. This is where I said, okay, listen, if the water is greater than or equal to the oil level, I want to return the water level to this thing. But if the oil is then greater than the water level, I want this one to take on the properties of the oil tag. So precedence here is that the water level, if it's ever greater than oil, it's going to return water as the oil level. And if oil is greater than water, it's going to return the oil level. And what I did there is I used that. Everything else is the same on these things. If I use that over here on the predecessor one, you can see it's using oil 1, and the background one, if I just move this guy a little bit so you can see the background is the same water. So nothing different there. So let me put this back on where I had it. Click on this guy right there, boom. So now that will cover that ratio correctly. So if I save this and download it, let's take a look here and see what happens. I'm going to actually implement this in my classes, I think, this fall. So if you look down here, you can see if I squeeze the water level, there's the water level. You can see it matches over here. Of course, the oil's sitting low because I haven't touched it. But if I squeeze the oil level, once it goes above there, it stays above. And of course, if I squeeze the water, oops, I got a loose connection here in my thermocouple, but the oil level is always going to be riding on top of the water level. So by doing this little cheat for this, I've taken care of that problem that kind of threw me for a loop the other day, is that complex code makes this work correctly with these two thermocouples for my upcoming classes to simulate. Anyway, I just thought that was pretty cool. And then I threw over here the ruling here so you can see that if this goes above, it matches that number, like I said. But then if I squeeze the oil, you can see it takes on the properties of the oil, which keeps them on top. That's pretty cool. I'm pretty excited with this. If you got any questions or you want to copy the database, please don't be afraid. But my upcoming classes, we're going to do this in my classes this fall. So, hey, thanks a lot, team. Have a great day. We'll see y'all later.